Hi everyone, welcome back to my channel. Today we are going to learn about non-determinism in LLMs. So when we're working with RAG systems or any AI system, it is important for us to understand variance and non-determinism. Suppose we are trying to make a very deterministic chatbot. Say we are going to set the temperature to be 0. That means we're reducing the creativity of the model and we want it to give more predictable outputs. So temperature 0 does not always mean that we have made the system we have solved the non-determinism problem, or we made the system very deterministic, but we haven't actually. Say we are going to give same prompt and run it multiple times. Say I'm suppose running something for a tax query, asking it to calculate GST for $15,000. If I run it once, it can give me 2,700. If I run it twice, it can give me something 2,699. So every time, even if our temperature is set to 0, we are going to get slightly different answers. So this may not be always the right approach for us to move forward with. So why this happens? So whenever where we're working with AI system or LLM, it's always based on the probability distribution, or everything is done based on how probable the answer is, or what is the next probable thing to be answered. So temperature only picks the probability distribution. It doesn't eliminate the floating point variance. So we are still going to have certain variance. Next thing we are going to keep in mind is GPU. So every time the numbers are calculated inside the GPU, or how GPU understands parallelism, that can cause different token probabilities to shift across hardware. So hardware changes also reflect in actual changes in the non-determinism. Next is even if we fix the seed value, it's going to have different outputs. There are going to be some change. So even if random seeds break the tool calls, streaming, context changes, and model updates, we often see that even in OpenAI, they also admit that results are only mostly deterministic with fixed seeds. So fixed seed does not always guarantee us the most deterministic answer. So how can we ensure that we get the right type of answers every time? We can enforce structured outputs. We can ask the LLM to give us answer in a forced schema, so that every time, whenever the calculation is in progress, it happens following a certain format. We suppose if I'm asking something related to GST, so I'll say first you give me the tax amount, tax rate, and base amount, and then you're going to calculate based on that, so that everything has a fixed schema, so that we can avoid different assumptions the model can make during the calculation. So prompt engineering can help. That is when we ask it to give it in a structured format. It can help us. We're going to understand what type of task can be given to what. Say something that is a creative task, something that is used for writing, we are going to ask the LLM to do it. If something is related to calculation or numbers or mathematics, it's best for us to use code to do the calculation, so that we avoid any changes or variation while the calculation is actually done by the LLM. We have computers in place that are very well advanced to do these calculations. We just need to make use of them. We can use code and we can format the answers. How are we going to reduce variance using just prompts? If we use ambiguous or vague prompts, say analyze this order and calculate taxes, it won't understand what exactly are we asking it to do. The answer can change because the LLM can interpret it differently in different runs. Whereas if we constrain what the LLM can actually do and give it some specific prompt, something that is precise, the higher chances that we are going to get same outputs all the time. This is going to maintain the consistency. If I ask something, extract the order amount, identify the category, apply GST rate from the provided table. So you have to return tax amount rounded up to 2 decimal places. Do not exclude reasons. That is very precise. So you're asking it to just show the calculation and give us the final output. We don't want it to give extra lines, so that can waste tokens, and as well as that is not very precise. So we have to eliminate underspecification. we have to have a single objective prompts, which will optimize for correctness, do not optimize for creativity. That is something that we have to specify. We can also use flowchart prompting here. We can provide examples to anchor the model to give us output in a certain format. So there's something that the agent always does, that is planning and then executing. But if it's not enforced properly, then this will kill the agents. Say when we are trying, we'll take an example to understand this. Say I have a chef can be the agent. So when chef wants to cook something, if the person decides a recipe while doing the actual cooking, how likely would the end result be deterministic, or what actually was expected? When you're deciding in every step what can be the next thing. So I don't know if I'm making a cupcake or a cookie, but I keep on adding ingredients based on what I like. So that would be incorrect planning that can derail us from what we're actually going to do. So it's important for us to explicitly complete the planning first, then and give LLM a set path to follow, give the agent a set path to follow. So we have to always bound the number of retries that the model can make. Next is to log everything, all the actions that the model is making, so that next time something wrong happens or something is different, we can always check what happened, what was the path that was followed previously, and what is the path that is followed now, so that we are just not doing any free form and trying to guess what might have gone wrong. So we have to limit the blast radius, that is locked plans, block prompt injection from adding unauthorized tool calls. An important aspect for us to deal with during anything that we're doing in AI systems or chatbots is preventing prompt injections. How are we going to enforce strong guardrails so that any prompt injection is avoided by our model totally? So that's about non-determinism and LLMs. Thank you so much for watching my video. Bye.